o'clock, so I'm going to go ahead and get started. Hey, real quick, by applause, how was everybody's first day at MIX09? And now real quick, by applause, how did everybody do on the tables last night? That's what I thought. So, hey, welcome to Principles of Microsoft Silverlight Animation. My name is Jeff Perrys, and I'm a senior experience developer with Wagner Edstrom Worldwide. Basically, my title is kind of a cool way of saying that I have a really nice job. I get to sit around writing Silverlight applications all day. I'm also the author of a book called Foundation Silverlight 2 Animation that was published by Friends of Ed. As an author, I would be remiss if I didn't take an opportunity to include a shameless plug for my work, so we'll go ahead and get it out of the way first thing. There's what my book looks like, as well as some of the comments from the reviews on Amazon.com. Now, the next hour is intended for anybody that has an interest in animating in Silverlight. But the goal of my session is not to show you every little detail about how to create a particular type of animation. Rather, I'm going to show you a variety of techniques for creating animations for your own objects. Along the way, hopefully you'll get excited and start thinking of ways that you can apply these techniques in your own applications. The time you're spending with me here today is about the journey, not the destination. You figure out where you want to go, and my material will be able to help you get there. In the interest of being as inclusive as possible, I'm going to start today with a brief discussion of storyboards, animations, and keyframes. From there, we'll take a look at vectors, frame-based animations, particle systems, and VR objects. As you can imagine, this is a lot of information to be covering over the course of an hour. I could easily discuss any of these topics for an hour or more. And so I'm going to keep it as high level as possible, but for those of you that are here for the code, I've included some of that in my presentation as well. Now, I'm sure many of you are familiar with storyboards already, but I wanted to do a quick review for anybody who hasn't had an opportunity to check them out. So we'll begin today with a simple question and see where it takes us. Where do storyboards come from? Let's assume that I've created a default project in Blend and I changed the default grid container to a canvas and just added an ellipse to this. If I want to create a storyboard in Blend, I just click the New Storyboard button, and Blend will present me with the dialog that asks what I would like to name my storyboard. In this case, I'm going to go ahead and accept the default. And then you can see that the interface changes. So what just happened? What did Blend do for me here? I can see that the timeline is a little bit different, and there's a red box around the artboard. The bottom line here is that as I'm working in the background, Blend is busy creating the XAML for my UI for me. The action that I just took basically results in this code being inserted into the XAML in my object. In my page, rather. So the takeaway here, and that's basically all it takes to create storyboard, by the way. So your takeaway here for storyboards is that they're containers. And as a container, they can contain one or many animations, or they can be left empty and used as timers. And when they're left empty, this is basically what they look like. You end up with a duration of 0. You start your storyboard, it expires immediately. You capture that event and then perform some action in the event handler. So if storyboards are containers that contain animations, where do animations come from? Oh, sorry, storyboards also can be created entirely from code if that's your preference. Okay, so animations. If I want to create an animation in Blend, the first thing I'm going to do is grab my timeline marker and drag it to the position. In this case, I'm going to move to 1 second. And then I'm going to grab my object on the artboard and move it. So in this case now, you can see there was a change to the timeline where there's a small oval shape marking the keyframe that I just created. And my object moved over there visibly. Here's the code that Blend created for me. Now this looks pretty complex, but I'm going to go ahead and highlight the new pieces. You can see the storyboard opening and closing tags. The new piece that was just added is double animation using keyframes, and you can see the begin time on that is 0. My target name is the ellipse object that I created. And the important part, the target property here, if you look all the way at the end of that, is translate transform X. I'm just moving my object along the X-axis. Inside of that, Blend placed a keyframe. This is the keyframe that showed up on my timeline at 1 second, and it's a value of 370. So, with that said, your takeaways on animations are that they're placed inside of storyboard containers. They're used to change the properties of objects over time. And the animation types that are available to you in Blend and Silverlight correspond to the data types that you're working with. So for example, a double animation would be used potentially to modify the width, height, left, or top of an object. Color would be used to modify fill or stroke. And point animation can be used to actually modify the positions of the points that make up the objects. Now there's something to keep in mind in animations when you're working with them, and that's that there are, again, these can also be created in code. There are a couple of variations on each type of animation. The first one is called a from-to animation. These are not directly creatable with Blend, but Blend supports them. If you go in and edit the code to create a from-to animation, it'll work just fine. Basically, from-to is a keyframeless animation. But what we're talking about right now is a using keyframes animation type. This is the type of animation people think about when you think of animation. You move an object, you create a keyframe, you move it again, and basically what's happening there is the process is automated for you. So we know storyboards are containers for animations. Animations are containers for keyframes. So that leads to our next question. Where do keyframes come from? Now here's another look at the keyframe that was just created for us in the project in Blend. But there's more to it than what you're seeing right here. There are actually 3 types of keyframes available to you in Blend. Now, Blend doesn't create a linear type of keyframe for you. You would actually have to manually type that in. But what a linear keyframe does is create linear movement between keyframes. There's a spline keyframe type that allows motion easing, which gives you an opportunity to create an organic look and feel to your animations. And then finally, there is a discrete animation type, which holds an object at one position until the next keyframe is reached, at which time the object jumps to the new position. So what do all these types of keyframes actually look like in XAML? What is Blend doing behind the scenes for us while we're working? One option here that's available to you in Blend, by the way, before I move to the next slide, is to actually change the type of keyframe with which you're working. You simply right-click the keyframe in the time objects and timeline, and if you select ease in or ease out from the menu, you're working with the spline type animation. If you select hold in, you're working with discrete. You'll notice here there's no option for linear. As I mentioned, there is no direct creation tool for that in Blend. Okay, so on to our code here. This is what a linear double keyframe looks like. The keyframe that we were just looking at looks like this. These two are functionally equivalent. A spline keyframe with no easing applied is the equivalent of a linear keyframe, which is why Blend doesn't use them. If you're creating keyframes, Blend will default to a spline double keyframe. Now, if I go in there and I create some ease on one of my objects, I'm going to get something that looks like this. And the difference you're going to see here is that I have a key spline that defines the motion curve for the way that my object acts as it approaches or leaves a keyframe. And then the last type that you're going to see is discrete double keyframe. And although this one looks just like the first two, it acts very differently. So now what I'm going to do is give you a look here at the effect these different types of keyframes would have on a simple object. So what we're looking at here is a double animation using keyframes. I'm animating a double value of my object. This is a translate along the X and Y using a linear double keyframe. This animation is 4 seconds long with one keyframe positioned at each second. As you can see, I'm getting a very linear, smooth motion on my object. If I take that exact same project and use a spline keyframe that has some easing applied, you can see I get a very different and more organic feel to the animation. Basically, my object is slowing down as it's approaching a keyframe and then slowly accelerates out of the keyframe on the other side. This is more what we as humans are used to seeing. You don't sit at a stoplight and when the light turns green, immediately end up going 35 miles an hour. You have to accelerate up to that speed. And then the last type here is discrete. Once again, discrete keyframe holds the object at the current keyframe until the next keyframe is reached, at which time the object will jump over to the next frame. Now, there's actually a really valuable use for discrete keyframes. You're probably looking at this going, what would I be doing with this? And I'm going to show you that in a few minutes. So I don't want to spend too much time on keyframes. These are pretty basic examples, but you should know that you can actually do some really cool work with keyframes. Both of these examples that I'm about to show you are projects that I had a hand in creating. This one here is in support of Microsoft's Oslo language. And basically these branches that come in and out of the menu system were hand animated. This entire application is roughly 5,400 lines of XAML code, which is not very much if you've been involved with creating UI. Of that 5,400 lines of code, 3,500 of it make up 27 storyboards that run all the activity in the interface. Now, this other one, some of you may have seen on the MIX website. This is a data visualization that shows the rates of obesity changing over the past 20 years in the United States. Now, aside from all of the stuff that's going on in the interface here, the slider across the top and whatnot, what you're going to see when I'm selecting these radio buttons is the act of a from-to animation. Basically, I'm just assigning a new endpoint where I want the t-shirt object to move to, and then executing the storyboard. And you can see I get a little bit of different activity depending on which set of storyboards I'm using. There's 50 storyboards that control the arrangement, and 50 storyboards, 50 for alphabetical, 50 by obesity rate. And so they have a little bit of a different look and feel to them. So moving out of storyboards, what we're going to start doing is taking a look at some procedural animation. And maybe you're looking at some of these going, hey, if I could do really cool stuff with storyboards, why would I want to bother doing anything from code? And the bottom line there is if I go to the Models Remix site again, it's going to look exactly like it did last time I was there. And every other time I go there, it's going to look the same. And while the action on my t-shirts looks a little bit random, the bottom line is if I go to a given year and flip back and forth between the switches, I'm going to get the same look and feel. So how do we get started in procedural animation? And the answer to that question is by using vectors. So what is a vector? First answer is it's a key component of procedural animation. This is a really easy way to give you a lot of control over moving your objects around an application. And what a vector does is describe a direction and distance independent of time. That's very different than what you get with a storyboard that relies on time units to move objects around your application. And then the most important thing about vectors that you need to know is that they're actually really simple and easy to implement. Basically, you create an empty storyboard, get it running, and as time is passing in your application, you just add the components of a vector to your object's XY position. So I'm going to start out easy here with an example of a one-dimensional vector. Just assume that the white area is a Silverlight canvas. My origin, 0, 0, is at top left. Positive x-axis runs to the right. Positive y runs down. What I'm going to throw up here is an ellipse with an x velocity of 1. Let's assume I have a storyboard in my application that starts when the application loads. A unit of time passes. My object moves 1 unit to the right. I restart my storyboard. It expires. My object moves again, and so on, and so on. Now, keep in mind when this is running in your application, it's happening in real time. So what you're getting is a smooth motion, not a slow movement like I'm showing here. A two-dimensional vector, to move an object in 2 directions, is just as simple. We have the same ellipse, only now I'm giving it an x velocity component of 1 and a y velocity component of -2. Now, keep in mind, since a positive y-axis is down, by using -2, my object's going to move up toward the top of my application. So once again, I have my storyboard. Get it going, my object moves 1 unit to the right, 2 units up, and again, and I get a nice smooth movement along a 45-degree angle. So now maybe you're looking at this thinking, yeah, this is cool, vectors are not too hard, I can figure some of this stuff out, and you want to include it in your application. The next thing you're going to run into is you're going to want to start bouncing off of boundaries. You're going to run into boundaries that are the walls, boundaries inside your application, or maybe you'll be bumping into other objects. Changing the direction of a vector is really simple. Let's assume that I have my same canvas. The blue bar is a barrier. And let's send an object along a vector of 5 minus 5. So I'm basically creating a 45-degree angle. I'm going to use a little bit of code to figure out when my object hits. This should be fairly straightforward. If the top of my canvas equals the bottom of my rectangle, I have a collision. At that point, I'm going to multiply my y component, in this case, by -1, which reverses the direction of my vector and bounces my object back into the application. So, sounds good in theory. What does it actually look like in code? Start out pretty easily by assigning our vector variables. I'm using a point here called object position to store the actual position of my object in my application. And then 2 double values, one for the x velocity, one for the y velocity. These values that I'm showing here are the ones that I was just using in that example. And now I'm going to move to an event handler. This is what happens. I start my storyboard. I've set up an event listener for the completed event. My storyboard expires immediately, and I'm into this handler. Inside of the handler, it's a fairly simple process for me to update my stored object position x and y by adding the x and y velocity components to it, and then simply updating the left and top position of my object in the application. What's really cool about vectors is how easy they are to start modeling the physical world around us. If I wanted to do something like add some gravity to this, I basically just have to create a variable to store my gravity value, and then pop in here and increment my y velocity by my gravity value. And then coming out of this particular event handler, the last thing we need to remember to do is to restart our timer. Otherwise, we'll get 1 tick of the clock, and our object won't keep moving. So let me show you an example of what this actually looks like when it's running in a program. I basically have one here that creates a ball drop that uses all of the techniques that I was just describing. I have vector motion, gravity, I am bouncing off the boundaries, and when I hit one of the boundaries, I'm reversing the vector in the way that I described. So you can see this has a very different feel to it than I had with the storyboards. It's a little bit more organic. It's a little bit more interactive. And I've even gone so far as to include an option to change the gravity in real time. So if I want the ball to float around the application, I can let it go. One of the things I like doing is to grab it and get it up here near the top a little bit, and then jack up the gravity and watch it drop. So that wraps up what I wanted to cover on vectors today. And next, what I want to take a look at is frame-based animation. So let's start with the question again. What is frame-based animation? When we're talking about frame-based animation in Silverlight, what we're trying to do is imitate the original flipbook techniques that have been used in animation for years. This is accessible to you in multiple ways in Silverlight. One would be using storyboards. One would be leveraging the Visual State Manager. Or you could do it strictly from code. Now keep in mind that complex frame-based animation requires some planning. I'm going to talk about this in a couple of minutes because it's not something that you just literally sit down and spit out a character and you're ready to go. So when I was preparing my presentation, I put some thought into how I wanted to handle frame-based animation. And it seemed to make the most sense to cover it by describing it in the context of sprites. I'm sure some of you have probably worked with sprites before. Some of you have probably heard the term tossed around and you're either not really sure exactly what it is or how to implement it in Silverlight. And then some of you are probably thinking, hey, cool, I had a sprite with lunch today. So while this is a sprite, it's not exactly the kind that I mean. When we're talking about it in Silverlight, what I'm referring to is a 2D or 3D image or animation that is going to become a part of my larger scene. If you're writing a game, you might be using multiple sprites for multiple characters. They were first used in the mid-1970s. They're obviously still in use today. When they were used in the 1970s, they were actually produced in the hardware, what we refer to now as a software sprite. And you have different methods available to you to produce sprite content for consumption in Silverlight. One would be to rotoscope live video. You could use a blue screen and then grab your video frames. Another would be to use claymation. An example of that is if you're familiar with the original Mortal Kombat game, one of the bad guys was done with claymation. You could use 3D software to generate your animations, or you could use vector artwork. The majority of you, when you're working with sprites, are probably going to be doing it with 3D software or vector artwork from your art department. So let me show you a project that describes how to create sprite movement with discrete keyframes. There's actually, I have 3 examples for you that leverage the different techniques that you can put into this. So with discrete keyframes, the first thing you need to know is that we're working with a series of images that are depicting our desired action. In this case, you might refer to it as a walk cycle or running or jumping. My images are going to be aligned either horizontally or vertically. And then what I'm going to do is use discrete keyframes to translate them at some interval along my storyboard. Since I know how wide one of my images is, in this case it's 720, I'm going to make that jump a full 720 pixels over and basically give you the illusion of flipping through the frames in rapid succession. So here's an image of the project I'm going to show you. Basically what you can see in the left, don't worry too much if you can't see the detail, but my images are in a container there called dog poses, which is a canvas. And while it's not applied at the moment, my dog poses canvas has a clipping path on it that will cut out all of the outside frames. This keeps your interface clean so you're not seeing the other frames that are staging. And then that is tossed into my root canvas. What I did in this case was create an animation called dog walk that uses an X translation. Every 1/10 of a second, I translate my dog poses canvas an additional 720 pixels to the left. And what I've done here is to use the speed ratio property of the storyboard to control how fast I'm actually getting playback. So let me show you what that actually looks like in an application. So here what I'm doing is I started out, I wanted to step through the frames really slow so you could see the effect. I put a frame counter up there on the top left. This walk cycle is 14 frames. And the dog was actually a low-resolution model walk cycle. You can see there was given to me courtesy of Billy Rivers. Now, if I jump in here and I modify the speed a little bit, you're going to see that all of a sudden I'm getting some smooth motion on my object. And what I've done is attach the speed slider to the speed ratio of the storyboard. And you can crank it up a little bit there and get a little bit of a faster action. So this gives you one idea for implementing sprite animations in Silverlight. Another technique you could use is to be using or manipulating the visibility flag on the individual frames of your object. So now what I have here is a female character. This one is 30 frames. There's a significant difference between working with the visibility flag and discrete keyframes in that the visibility flag is much easier to set up, very fast. The dog project, when I actually received those frames, I got them at about 6:30 at night. The entire project was built before 7 p.m., so it's not like it's painful for 14 frames. When I start looking at 30 or maybe 60 frames for an action, I'm going to probably think twice about setting that up because it takes a lot of math to figure out how far I'm going to move on each step. So this is the first 4 frames of a walk cycle animation. First thing I'm going to do is add my images in XAML. So here's a shot of my objects and timeline in Blend. You can see my images there. Each one holds a different frame. Now this time I created a storyboard and I'm going to use the storyboard to change the frames. What I've done here is, for example, on the very first one, at 0 on my timeline, I changed the visibility flag on this particular image to visible. At 1/10 of a second, I shut it back down and made it collapsed. The nice thing about working with the visibility flag in this way is you can grab those 2 keyframes and copy and paste them onto all the other ones, just positioning where you need them. And if you're working with 30 frames or 40 frames or 60 frames, it goes by pretty quick. And the end result of that one looks like this. So here's something really cool about this. The dog animation was 14 frames that are 720 by 480 pixels. This one is 30 frames that are 512 by 480 pixels. These are transparent pings, so they could go over the background in a way that allows the object to move along if it was a side scroller or something of that nature. This barely touches my processor on this system, and this is not a high-end Dell. Basically, I run about 10% usage on my CPU, so this is a pretty effective way to create an animation in Silverlight. So now, a little bit earlier, I was talking about how it takes some planning to create some complex character animation. And what I want to show you is called movement flowchart. If you're creating a game, you need to map out every movement that every character makes and how they relate to each other. So there's 3 different ways you can go about doing this. The first one is called a linear movement flowchart. This goes directly from one move to another in a fixed order. So it doesn't create a very deep user experience. As you see these come up here, you'll see that I can't run from an idle state. I can't jump from a walk. The next type is referred to as a radial flow chart. This one is less restrictive than the linear, but it's still a little bit limiting. Here I have the same basic set of moves, but I always have to return to my idle state before I can move to one of the other motions. Now you'll notice where the white arrows are drawn in here. You're probably going to want to consider transitional movements. If I have an idle movement and a walk movement, I probably need an idle to walk movement. And then the final type, which is the most robust and also the most complex, is referred to as a descending movement flow chart. This one starts out with your base state. In this case, we'll say idle. And then you draw in every movement that's possible from your idle state and the relationships to the base state. The next step is to draw another tier in the flow chart that repeats our states and then the relationships between those states. So if you take a look at an example here in the middle row, the second one from the right, hit. If I am in a hit stance, my options are to either get hit or return to idle. The parentheses along the bottom row indicate that I return to a higher position in my flow chart. So for example, if I'm in the hit position and I get hit, I move back up to the top, the right-hand block in the middle row to get hit. I have three options from there. I can die, I can get hit, or I can return to my idle movement. And you'll notice here that in the bottom row, the die block has no parentheses on it. That is because there is no movement that follows death. That didn't come out quite as I intended. Okay, linear, radial, descending flowchart types. There's a fourth type I'm not describing here in detail. You want to avoid it at all cost. It's called a condescending flowchart, and it looks like this. My wife made me promise if I used this slide that I would tell you it wasn't about me, so it's a fictional me, somebody else, not me. So the final way I want to look at sprite animation is through the Visual State Manager. And I love leveraging the Visual State Manager because it handles shutting down the storyboards that aren't supposed to be running and starting up the ones that are just by me calling with one line of code, go to this particular state. So what I've got here is a little application I wrote. Even though there doesn't look like there's a whole lot going on in this application, I have actually a whole lot of stuff going on in the background. I have an empty storyboard that's running, waiting for me to make this guy move to apply some X velocity to it. Here I'm combining with vector movement to create secondary motion on my character. And basically, the animation that's running on this knight character right now was called with a single line of code by calling the Visual State Manager and saying, go to the idle state. And that's what you're seeing. The other thing that I have going on is I have some code in there that is waiting for me to start pushing keys. And what I can do when I push an arrow key is switch from the idle state to a walk state. And then the other state that I have in there is a run state. So you can see the effect this has. Each one of these times I press a key, all I have to do is call one line of code to get to my state. The downside of doing this with the Visual State Manager, if you were at the keynote this morning, they talked about transitions. I don't have the ability to put my own custom transitions into the State Manager yet. I'm hoping I'll see that sometime soon. This would really give me a very powerful sprite animation tool. So that wraps up what I want to cover on frame-based animation. The next thing we're going to take a look at is how to create particle systems in Silverlight. Particle systems are often used to model fuzzy objects. So if you're going to see CG movies and you're looking at fire, smoke, explosions, or water, you're probably looking at a particle system. The basic model for a particle system in any of those cases is the same. For each unit of time that passes in our application, we're going to possibly create new particles based on some condition, potentially remove old particles based on some condition, typically a lifespan assigned to a particle. And we're going to update the position of our existing particles in our application. So let me give you an idea of what that looks like in C#. Once again, I'm using a storyboard timer here. Empty storyboard. I started it. set up a completed event listener. This is my handler for that. This is the empty handler. The code that goes inside here basically starts out with a simple for loop. In this case, I'm using a list called particles. You can see particles.count there, that is going to step through each of the particles in my application. My next step is to update the position of my particle on the screen. This is done. My particles have a velocity x and velocity y. Once again, I'm using vectors. So I'm going to use a canvas set left and a canvas set top to reposition my particle. I'm going to update the age of the particle. So I assign an arbitrary value referred to as lifespan. When a particle is created in the application, its age is 0. Its age increases as the application runs. And if my age happens to exceed or equal the lifespan, I'm going to remove the particle from my application. And the way that I'm going to do that is start by pulling it off of the layout root. Then I'm going to remove it from my particles list. And then I have a method I wrote called create particles, which basically generates a new particle to replace the one that I just killed. And then finally, again, I have to restart my storyboard timer to make sure that my particles keep moving around the screen. So let me show you what the whole function looks like together. That's basically all of the code I just showed you put together into the event handler. So the end result of that is a basic particle system. Here, when you see the particles blinking off, they've reached their lifespan. Their age has exceeded or equaled their lifespan, so they're removed. When you see new ones blinking on, that's me calling my create particle method to create a new particle. I'm sure many of you are sitting there going, how am I going to apply this? And I'll show you a couple more examples in a minute. One of the things you want to keep in mind when you're creating particle systems is ways that you can make particle systems useful and interesting for the end user. So how do we make interesting particle systems? The first thing we could do is randomize. You can see this in the application I just showed you. I had randomized colors, scale, lifespans, velocity, and also the opacity, even though that's not on my list here. Even though you have a particle that's part of a system and is being moved with vectors, you can still use storyboards on the particles to create some secondary animation. And I have a good example of this I'll show you in a moment. You can let the user modify the system. This isn't realistic all the time, but sometimes with explosions or the examples I'm going to show you here, it goes a long way to drawing a user into your application when they have the ability to tweak some sliders and see what changes it makes to your system. And then the last thing you can do to create an interesting particle system would be to use an emitter. Now, a particle emitter is actually very commonly found in 3D. And what they do basically is allow you to define the shape or area of a system. Now, in a 3D context, we may have a sphere that's generating a waterfall. Particles may be interacting with other spheres as though they were rocks and tossing the particles around. I haven't done a whole lot of collision work with particle systems in Silverlight, but I'm hoping now with the hardware acceleration that I'll have the opportunity to try that out. In Silverlight, we have pretty much two options for how we're going to create our particle emitter. We can emit particles from a point, or we can use a rectangle. All objects are basically surrounded in a bounding box, which you can get by querying the width or height of the object. A rectangle technically is just a range of points, so both of these are pretty much the same. And then the other thing that's kind of cool about emitters is that they can be animated. So now you have an opportunity to create an animated emitter that will blast particles around your system, your application, and you can create secondary animation on your particles to make it even more interesting to look at. So let's talk about how we would implement a particle emitter in Silverlight. First step, name your emitter object. This makes it really easy to access from code. Then all it takes is to generate your particles based on the location of your emitter in your application. So a PowerPoint version of this looks like this. Let's assume this is my layout root canvas. Throw my emitter up there, as my emitter moves, I'm going to generate particles, and I'm going to generate them to the layout root, not to my emitter. So let me show you two examples of particle systems I have here. One is a comet. The actual comet itself is being moved procedurally with code. There is no storyboard moving the comet. The particles that are being generated are a single object that's being instanced into my particle system on the fly. And each particle has a secondary animation on it that I believe was called something like flicker. At the time that I generate the particle, I'm randomizing the opacity, and I'm modifying the speed ratio of the flicker animation on my particles. This gives some randomness and actually kind of an interesting shimmering look to the particle system. Now, the other system that I have to show you mimics a garden hose or water fountain. You can see that in this one, my particle count is up in the top left-hand corner. It doesn't just immediately start blasting 150 pixels or particles on screen. I count up starting at 0, and then I add the particles at an interval to give me an interesting build-up effect. And you can see that what I've done in this case is give a fair amount of control to the user. They can modify the number of particles in my system. They can modify the gravity. They can modify the velocity at which the particles are ejected from the emitter. And they can control the spread. Because I leveraged a timer to add my particles to the system, if I were to come in here and modify my particle count with this slider, the number you want to watch is in the top left-hand corner. If I move this all the way to the right, you're going to see it count up, not blast up to 250. That number increments each time a particle is added to my system. Similarly, if I pull it back the other way, it will count down as the particles are removed from the system. Now, as I showed earlier with the ball using the vectors, here again I'm using vector motion to keep my particles moving around on the screen. If I pull the gravity way up, you're going to see the effect that that has. If I push it down, the particles are going to float a little bit more around the application. Now remember earlier when I was talking about vector, y movement on the vector, or x movement for that matter. Notice that my y velocity max is minus 15. I'm ejecting my particles up toward the top of my application. To move up toward the top is a negative number. And I can crank that up if I want them to push out a little bit harder, or pull it down if I don't want them to go quite as far. This gives me a little bit more of a fountain effect. And then the spread I have, I'm basically using a range based on the width of the emitter rectangle to create a spread. Right now, these are coming out of a spread of about 2 pixels or so. If I bump that up a little bit, you'll see where they come out a little more evenly distributed across the top of the rectangle. And if I turn that one all the way down to 0, you basically get a straight stream shooting up. So that one wraps up my quick overview of particle systems. The last thing I want to take a look at today is a Silverlight VR object. I'm sure probably most of you are familiar with VR objects. What these mean to us as developers is that we are creating essentially a frame-based animation that is user-controlled rather than controlled by a storyboard or code. And they really give you a way to allow your users to explore objects online. You could do this through a 360-degree view. I've seen interesting product assemblies done with VR, innovative product packaging, or time-lapse photography. There's two basic approaches when you're creating VR objects. The first type is a flipbook approach. I created one of these a couple years ago in JavaScript in Silverlight 1. Basically, what this requires is that you're going to load all of the individual images that make up your VR, and then you're going to flip forward or backward through them programmatically like they're a deck of cards. Based on my experience, they're not ideal because managing the images can become cumbersome, and it takes far too long to set up new items. What I want to be able to do is just push an image into this thing and have it ready to go. The other approach is to use a single image translation. And in this case, we're going to load a single image that consists of all of the frames that make up our VR object. And our user, based on their input with the mouse, is going to control the translation of the image. In my opinion, this one is a better choice because it's a single image, so it's much more manageable. And based on the control that I wrote for it, is actually easy to set up. Now, when we talk about VR objects, there's actually two different kinds out there, and you may not realize, if you've seen them before, that there's a big difference between them. The first is a single row or single plane object. Basically, what this encompasses is some number of frames that basically rotate your object anywhere from, maybe 90 degrees on up to 350. This is the first few frames of a full product rotation I have on this bed. The other type is a multi-row or multi-plane. These ones are considerably larger, more complex. Here's the first few frames of the first few rows of a VR of a wooden artist's figure. So we see these things up here on the screen. Where do I go to get my VR images? Again, you can start with the 3D rendering program. There's a lot out there, really good prices. They usually come with a model library if you wanted to experiment with it. You could render out some images, load them up into a control, and see how they work. You could do self-shot photography. Everybody has a digital camera. It's easy enough to run out to a kitchen store, grab a Lazy Susan, mark off 10-degree increments, rotate your object, and take your photos. The downside of doing it that way is the end images that you're working with have a tendency to require a bit of cleanup, and that can actually get pretty time-consuming. Then your last option is to use a professional service like Photospherics, who was kind enough to provide the images that I'm working with today. When you're dealing with a professional service, the benefits that you get are that they're using stable, specialized rigs to take the photos. They're going to shoot to your precise requirements. If I tell them I want a single plane image with a single plane object with 18 images, that's what I'm going to get back. And then they also have the capability of doing multiple planes. When you're using a professional service, they use a special rig that has a large C shape on it that the camera rides on up and around your object. That's what keeps it stable and keeps your images lined up the way you need them to be. Obviously, there's a cost there. They don't give the images away for free. So if you're running a small business or you're trying to get your products up online, that's something you're going to need to account for. So in the end, you're going to be sitting there with a large pile of images. If I'm working with a single plane object, I'm likely to have 10 or more images in a single row. If I want to do a full 360-degree spin, you could actually go up as high as 1-degree increments and end up with 359 images. That will give you very smooth motion, but it's going to be very cumbersome. What works pretty well is around 7 to 10 degrees, so more likely you're going to end up with around 35 images. What if I have a multiplane? Now I'm looking at 10 plus images, and I could have 5 or more rows if I'm doing a pretty good view of my object. Think about that for a minute. If I have an object that has 10 rows on it, and I'm doing 10-degree increments, that's 350 images that I have to manage to somehow arrange into a single image for my control. The key word that you're looking for when you're doing that is contact sheet. A program like Adobe Photoshop or a freeware one that I prefer is called Irfan View. They have scripts or automated processes to create contact sheets for you. What a contact sheet actually does is take all those single images you have, process them, and basically produces a single image. Now this gets a little bit tricky when you're doing it on your own because you have to have some kind of intelligent naming convention to keep track of the rows and columns for each of your objects. And if you're doing a multiplane, you have to make sure that the objects in each row line up with the shot that you wanted from the row before and after. The contact sheet, if you're using a professional service, you'll get a large pile of files. You basically just point to them and the contact sheet produces the image fairly quickly. Now keep in mind here that these particular images are 600 by 600 pixels. So if you're dealing with 10 images, you're dealing with 6,000 pixels. A couple of these examples that I'm showing are JPEGs that are 34,000 pixels across. And the nice thing about using a JPEG is that you can control the compression on them a little bit. So I have this control that I wrote for doing VR objects in Silverlight. If you're interested in the code, You can visit my publisher site at friendsofed.com and download it with all the other files from my book. If you want to learn about it in gross detail, feel free to grab a copy of my book. The control itself is actually pretty simple. I have a canvas that I call image control that has a clipping path on it. Just like I showed you with the dog animation, the clipping path is intended to clean up anything outside what I want the end user to see. Inside of my image control, I have a rectangle called mouse control that I use to gather input from the end user. And then behind that, I have my image called active image. This is where my giant image sits. So let's take a closer look at that. Here's the middle frame of the 9 frames that I showed you for this wooden figure. This is actually one of the really large images that I have. So let's assume that what we see inside the orange box is what's visible to the end user in the application. Now, the area that I just highlighted blue represents my mouse control rectangle. This is where the end user can move their mouse in any of these directions. I'm collecting input on my control, and when I figure out which way the mouse is moving, I translate the object, the image. Now, keep in mind that what you're seeing here is a PowerPoint version. The object slid. It doesn't actually slide. We're recreating basically the movement of a discrete keyframe. So I know my frames are 600 pixels wide. It actually jumps 600 pixels across. So I have a couple of examples of this to show you. The first one is the bed object that we were looking at. 600 by 600 pixels is actually pretty good size in your browser. Chances are you're probably going to come up with smaller objects to deal with, but the goal that I was going for with the control is to give as much control to the developer to provide the experience that they want to the end user. So I've done 2 things. One would be to allow you to grab the object with the mouse and move it, and then the other is to have the object move opposite the mouse, which is more akin to moving the camera around the object. And I know you can't see that with me working the mouse up here. So if I grab my object by pushing down the mouse button, I can drag around this, and you basically see that I get a full 360-degree view of my object. And the last example that I have for you today is this small toy Mini Cooper. This one is a multi-plane. I have the option here of moving this one along the single axis just like the bed, but I'm also given the opportunity to move around the object in a little more depth. So you can probably imagine, if you're a business trying to put your products up online, the kind of interactivity, the kind of look and feel you can give to your users, especially if they live halfway across the globe and don't have the ability to come into your store. So that about wraps up what I had for you today. I want to thank everybody for coming and spending time with me today. I do need to give you a reminder that your eval forms are in the back of the book, and if you would be so kind as to fill one out, I would appreciate it. I will be in the bookstore tomorrow from 12 until 12:30. If anybody has any questions or wants to stop by and say hi, I don't bite. You get an opportunity to check out my book also. And now I'd like to take a few minutes and take some questions. And for the first 3 people that pitch me softballs, I have a copy of my book. Thank you. No questions?
The main reason I came to this is we were trying to build a ticker to make a smooth ticker, and it seemed with animations that it would sometimes then jump, and I was wondering what you would recommend is the way to make a smooth text-based
Probably, so the question, if anybody didn't catch that, was trying to make a smooth ticker that was acting a little bit jumpy. Probably your number one culprit there is the speed of your system. One of the things that I do to control the speed of the animations in Silverlight is in the object tag add a max frame rate with a value of 30, and that has a tendency to smooth out a whole lot of the action that's going on in there. I feel like I've seen the kind of thing that you're describing in my own work, and that really helps mitigate the speed, the refresh rate that the machine can handle.
I have a question over here.
Oh,
Do you prefer to do code and animation? Do you prefer to do animation in code or in XAML?
I feel like Blend is such a powerful tool in creating the interfaces and allows me to get very hands-on with the XAML that I prefer to create most of my base objects and animations there. I found, especially if you're generating many animations from code, it's a little bit harder to read through. My preference is to be a little bit more explicit and have the opportunity to check out what my code is doing at a glance rather than spending a little bit of time debugging and figuring out what my code was intended to do, especially if you shelve it for a couple of months and then come back to it. So I'm going to hit this one back here.
Am I live? Yeah.
Yep.
Do you have any suggestions? We have a set of older assets, basically classical play cell animations across the screen kind of thing. Do you have any guidance for incorporating that into more Silverlight animation? I mean, what do I do with all these old assets? Essentially PNGs, you know, kind of old 4-frame animations.
Oh, sure. Well, you could use any of the techniques that I described here to create those type of animations, the sprite animations, if that's what you wanted to do with it. Keep in mind, so one of the things that I didn't actually mention when I was working with the knight character, for example, when he's running right or running left, I changed the direction he's running by just modifying the scale by -1. So you have a lot of flexibility there in the way that your characters are implemented in your Silverlight application.
Okay.
If you want to come down here, I got a copy of my book for you. Sir?
So what kind of performance advice can you give somebody who's doing something like cell animation where I have a bunch of loose files and I don't know if I can do a big layered image because I'm overlaying things on top of each other?
I guess I would probably need to see more of the type of work that you're doing. The performance that I've seen seems to work pretty quick on images. So if you're working with a ping file, I feel like I get better performance out of that working with something like the visibility flag versus a big pile of vector artwork. Okay. And in a lot of cases, you can do some really cool stuff with vector artwork that doesn't need to be terribly complex. But I've seen a lot of characters that I've tried to generate as vectors that end up being bigger than the ping file. And that wasn't the intent of what I'm trying to deliver to the client. So I guess it's kind of weighing your options there and then figuring out which one more effectively suits your needs for a given situation.
Okay, thanks.
Paige?
Yeah, I noticed you used empty storyboards and would restart your animation to create a loop. And I was wondering if there's any advantage to doing that as opposed to, say, a dispatcher timer that has a tick cycle. Is there any advantage to choosing that?
This is kind of a subjective question. I actually knew, I had a feeling somebody would ask. There's probably 3 different ways to do that. There's using the, I don't remember the exact terminology, but there's using the refresh rate of the browser, the dispatch timer, and then the empty storyboard. Use whatever you feel is working best in your applications, whatever looks best. I started out using empty storyboards when everybody said, check out the dispatcher timer. It does the same thing. It's a little more smooth and effective. I actually prefer the storyboard because I feel like it gives smoother animation and I have more control over it, I feel like, where I could just jump in there and kind of modify it on the fly as I'm working.
Thanks.
I have a couple questions, and I'm probably going to run out of here on a rail because I'm coming from a Flash background. I noticed basically you were showing stuff where it went frame to frame and was snapping between images. What does that do to your file size? Doesn't it just balloon?
No, not at all. You actually have the option, I'm sure you could do the same thing in Flash. If you prefer to keep your image assets external, you could do that. For the purposes of the demonstration, I just put them all in one. If I was writing that for an actual game application, I would create an object called dog and just put my images in there and the animation in there instead of loading it into my main application. Now, depending on the size of the thing that you're using, of course, these are gigantic images that we're here for the demonstration. If I'm doing a smaller version of that, like maybe the knight character, it's not that big. You get the benefit of the zip compression in the archive that Silverlight generates. So I guess, again, you're trying to find your balance between how many characters do you have, what do your assets look like, whether they're vector or image, and then what is your end user experience? Are you dealing with somebody that's still on a 56K modem that's going to have to take some time loading these, or do you know that you're targeting higher speed pipes?
Okay, thanks.
I'd like to follow up his question on timers. Do you know if they did anything in Silverlight 3 to address, if you will, the timer disparity problem?
So when I spent some time thinking about this, I think how come there isn't just a way to make time pass? My background is actually in 3D, and your basic case in there is you put your things in a choreography, your objects in a choreography, and time is passing as you're animating. I think the point of Silverlight was they really approached a business application, and so then all this other kind of stuff kind of came along behind that, and they're kind of backfilling it in now. I don't know any of the details about any of that. I'm just kind of speaking on my own opinion there. But I don't mind using the way that the storyboards work. They're very fast to set up, and they give me an easy set of event listeners or event handlers that I can grab off of the storyboard when it's running. So it gives me some more flexibility. Anybody else? Okay, thank you.